Hello again, it's Andy from the Science of RVs, and today we're going to talk insulation, insulation, insulation. Okay, so why do we need insulation? Well, I can think of three reasons why we need it. We need it to keep our vehicle warm or cold, so stop temperature changing to the outside temperature. We need it for sound insulation, the dreaded no privacy on the toilet. Um, and also we have equipment that heats and cools. So for example, our fridge has a degree of insulation built in. We might choose to do something about that and increase its efficiency so it reduces power. And likewise our hot water tank or our hot water system, there's losses there that we could probably minimise, which will help in our power demand. So those are the three subjects we're going to talk about. We're going to focus primarily on thermal insulation. How do we keep our vehicle warm or cold? And then we'll move on to the other issues very briefly at the end. So, what is the science of heat loss? Okay, there's three mechanisms of heat loss: convection, conduction, and radiation. Convection, we all understand, I think, is where we have a radiator or a heat source in a room and the air travels up the wall, it travels along the ceiling, it comes back down the other side, and you get this circulation of air in the space that you're in. Likewise, if you heat up a fluid in a kettle, convection currents will be set up in there. So that's transmitting currents in the air. That's a mechanism that we want, and we're not going to interfere with. So we'll put that aside. Conduction is where heat travels within a medium. So I get a metal bar, I heat it at one end, the other end's going to get hot. So that's just transmission of heat through a medium. We're going to focus very much on that. And then the third element is radiant heating. And this is where, at an atomic level, atoms get excited and transmit, if you like, a beam of energy from one place to another. So if it hits a solid surface, it'll heat up that surface. So we need to worry about radiant heat as well. But we're going to start off with conduction. Now, up above my head, as usual, I've put up a table that measures heat conduction, and it actually measures conductivity. And I've included 5 standard materials, let's say. Rock wool, which is loft insulation. It's not dissimilar to this. This is actually a fibre insulation that's actually sheep's wool, but you can get a fiberglass version of this, which would proprietary brand is rock wool, and it's the kind of stuff that's commonly used in your loft, either as a roll or as a board. So I've said that let's call that 1. That's my baseline. So I'll compare everything relative to that. So if rock wool's 1, steel has a thermal conductivity of 1,255. Remarkable. It's over 1,200 times more conductive than this. And the way they measure that is they have a piece of material, they have what temperature one side, a different temperature the other, and measure how much energy it takes to maintain a temperature difference. Water is 15 times more conductive than our rock wool. So if I get this wet, it's going to be a fraction of its performance. And that's where condensation comes into the equation. Glass, just a sheet of glass, not special glass, is 20 times more conductive. And wood, depending what it is the same or up to 3 times more conductive. So that puts it in the scale. So if we put that into the context of, say, converting a van, and I line my van with insulation, there's a couple of things to know. My insulation is going to be an awful lot thicker than the walls of my van. So I have to factor for that. So if my metal is a few millimetres and my insulation is 30, let's assume this is 10 times thicker. That means it'll conduct a tenth of the heat. So that 1,200 becomes 12,000. So if I have 1.2 millimetres, 1.2 metres, about 4 foot of insulation, and I have 1 millimetre of metal, that 1 millimetre of metal that I can touch will conduct as much as a whole 4 foot of this. That's what it says. So if you convert in a van, you get any metal that you can see it's going to hoover up all that heat out of your vehicle, or it's going to hoover up all the heat outside and get it into you, and it's going to feel really hot compared to what the performance of this is. Likewise, windows are a killer. They're 20 times more, and again, windows tend to be really thin. So if I've got a window that's only, this, and I've got insulation that's this, the heat transfer from one side, the inside of that window is going to get hot really quickly compared to how long it takes for this to happen, because of it's 20 times more conductive and it's a lot thinner. So by the time I factor that in as well, the windows are something like 200 times more conductive, or will transmit heat 200 times more than this. So if I have 50-50 windows to insulation, my windows are going to bake me. And I know that anybody who lives in a mobile home, an RV, a motorhome, will say, yeah, we have to do something about the windows. So we have to tackle materials for the kind of materials around us. So that's just to give you a little bit of context of what you're trying to manage when you look around your vehicle. So what materials are available to us? So there's basically another table I've just put up. There's an awful lot of materials. They basically sit into roughly, in my mind, 4 families. Now there's an awful lot more than that, but these families I've picked because they're the most likely to be used for insulation in the home or in an RV, and they give the kind of range of numbers you can expect. So the table I've just put up now has rock wool again, which is a mineral wool insulation. If I used sheep's wool, it actually doesn't perform quite as well, but it's not far off. So you'd need slightly thicker to get the equivalent performance. So I've normalised thermal performance based on rock wool. So you'll see rock wool, you'll see Celotex, which is a rigid foam board, PAR material it's called. An expanded foam is also, once it's set, is in that family. I've used a multi-foil type product, which is a foil's like a bubble wrap. It's like bubble wrap, this stuff that we all like to pop. It's like this with silver foil on the surface. And that's a family. And there's a family at the bottom called Aerogel. Now I've only put Aerogel in because it's very high performance. It's 2.7 times reduced thermal conductivity compared to rock wool, but it's horrifically expensive. But what it is extremely thin. So being 3 times better, if I need 30 millimeters of rock wool, I only need 10 millimeters of Aerogel. So it has use where space is really limited, or we're trying not to disrupt say ancient features in a listed building and stuff. So we won't go into Aerogel per se, but I just wanted to make you aware that if you have a very, very limited area and you've got big heat loss in that area, very limited thickness, then you might want to go and have a look to see how Aerogel can help you, but we're going to dismiss that for now. So let's look at rock wool, Celotex and multifoil. Rock wool, like I said, very, very common material. Lots of people use it in loft insulation. You can get it as a semi-rigid board that's very easy to cut. Make sure you wear a mask and gloves and a paper suit, preferably. The old type materials were very, very itchy. The newer ones are much less so, but you should still wear a basic mask. But they are relatively thick. If you're going to insulate a home in the UK, you're advised to put 300 millimetres, what's that? 10, 12 inches, crikey, of insulation up in your loft. So it's quite thick and it has to stay fluffy. The mechanical properties of this are so good because it has lots of little air gaps inside. The moment you compress this, then you're going to get different properties and you're not actually going to get the same performance. It becomes more conductive, so you're not going to get the same performance. So when people start shoving this into nooks and crannies and little gaps, they're getting insulation, yes, but they're not getting the insulation they thought they were getting. So there's a much better alternative to this, which I'll mention in a minute. So this is number one. Now also I've said, let's assume that the cost of this insulation is also 1, and that's also normalised. So for the same level of thermal performance, what does it cost? And that means that, for example, Celotex is a better insulator, so it's thinner, so I don't need quite as much of it, but it's more expensive. So let's factor those two into account. So pound for pound, what would I pay for the same insulation performance? So Rockwool is my baseline. Celotex, which is this rigid board, is 1.6 times better performance. In other words, I probably need about 2/3 of thickness. Simply, if I need 100 millimeters of Rockwool, I'll only need about 50 to 60 of Celotex. So it's very useful, it's quite rigid, and it often comes with a silver foil on one surface. Multifoil, which is this bubble wrap, is only about 3.5 millimeters thick. Now that serves a different purpose. Lots of people use it in converting vans, for example, and they attach it to the skin of the van. That's not what it's for. Multifoil is not a conductive barrier fundamentally, it's a radiant barrier. So if I put it in contact with the surface of the van, and because it's got a silver foil on both surfaces, it's going to conduct that heat really well, because metal conducts 1,000 times better than insulation material does. So to have a radiant barrier work, there needs to be a gap between, and there's a little diagram, there needs to be a gap between the radiant surface and the heat source, so the radiation can travel, hit and bounce and be reflected. If they're in contact, they'll work by conduction, and multifoil is a bad conductor, as you can see, in terms of its thermal performance. It's worse, but it's actually much worse. So used in the right way, multifoil is great to manage radiant heat. Celotex can manage radiant heat because of its foil surface. We'll come on to that in a second. Rockwool cannot. It's not going to manage radiant heat, but it will manage conductive heat very well. So those are the options to us. So you can see in terms of ranking, Celotex or expanded foam materials are just over 1.5 times better performance-wise, like for like, than the Rockwool insulation. But that comes at a cost. It's also about, pound for pound, 1.7 times or 1.8 times more expensive. So you pay for that thinner material. So those are the two main trades. Multifoil is horrifically expensive because its thermal conductivity performance is poor, and it's very, very thin for what you pay, which is terrific. So long as you're using it as a radiant barrier, it becomes cost effective. So let's just quickly give you some numbers. The Celotex board, you're going to pay around about £7 per square metre sterling for 40mm thick Celotex. You're going to pay, for foil, you're going to pay around about £2.50 a square metre, but it's only 3.5mm thick. And for Rockwool, you're going to pay about, for 100mm thick, you're going to pay about £6.20 a square metre. So you can use those numbers to do your calculation. So if you buy 100mm Rockwool, you'll pay £6.20 per square metre. To factor the Celotex, that'll cost you about tenner a square metre for 60mm on these numbers. So you can see it's £11. It's in that £10 to £11 bracket. And for foil, it's £2.50 a square metre for a thermal foil. So I'll just give you some numbers there. So where would I use each? Well, if I want to manage radiant heat, then I'm going to want a silver foil, but I must have a gap between the skin that's radiating the heat and the reflector. So I can use, for example, Celotex and put the silver side towards my wall, as long as there's a little cavity behind. So in contact, then I will turn it the other way around. I'll explain that in a minute. So Celotex is great because it's a semi-rigid board. You can put it in, you can use silver tape that you can buy with it to tack it in place, and then my preference is to use expanding foam around the periphery to secure it in place, every patch. You can glue it on if you want to, you can screw it on if you want to. It's a very, very forgiving material. The loft insulation, you can get semi-rigid battens, so panels, so it's not like this, like a roll. It's reasonably stiff. Again, you can glue that on, but trying to glue this onto something ain't very good. You'd have to use some pretty manful glues to make that work. But again, if you've got a stud partition or a studding, putting this in is terrific. You can just wedge it in, make sure there's no gaps, does a great job, and it's relatively cheap. So lining the walls of my vehicle, I'm going to use either Celotex or a Rockwool mineral type product. For me, in a vehicle, I think my preference is to use Celotex because it's easier to put in and stay put. I can cut the Celotex but not the foil, so I can bend it around radiators and stuff. That's quite easy. If I'm going to batten out, then I may actually consider Rockwool. And I might consider Rockwool because its acoustic properties are very, very good. So it deadens sound very, very well. So it gives you a bit more privacy. Celotex has some properties, but the Rockwool, if you're trying to deaden sound at the same time as insulate thermally, then I would be going down the Rockwool route. Now, when you insulate your walls, your wall will become cold if the outside world is cold. Inside your vehicle will be moist air. It'll be moist air because we breathe out a load of moisture. We generate moisture in cooking just by being there. That moisture will hit that cold surface, and the moment it does, it condenses, and it goes from being a vapour to being liquid, and you get water running down the inside of your wall, or water vapour condensing, and that causes potentially two problems: corrosion or mould. Both of those we want to avoid. So you want to stop warm air hitting your cold surfaces, and you do that through what's called a vapour barrier. Now, the Celotex that comes with a foil, that foil isn't primarily designed as a reflective surface to manage radiant heat. It's actually the vapour barrier, and you should traditionally fit the Celotex with that vapour barrier on the inside, on the warm side, and then once you've filled the space, the silver tape you can buy with it, you use to close all the gaps, and that stops moisture being able to get on the other side of the insulation. If you're going to use it as a radiation barrier, and you have a cavity behind, you turn it round the other way, and then you're going to have to fit a separate moisture barrier, sorry, a vapour barrier, on the inside. Now, a vapour barrier could be something as simple as just plastic sheeting, just tacked on, just as long as it stops moisture being able to get past it. But you must do that, otherwise you run the risk of moisture problems later. So that's how you manage Celotex. So like I said, the foil surface is there primarily as a vapour barrier, and traditionally it goes on the inside. If you're going to use it as a radiant barrier as well, and it's very good at that, you'd put it on the outside and put a separate moisture barrier on a vapour barrier on the inside. Rockwool, if you put that in, then once you've finished installing Rockwool on your stud, again you're going to want a vapour barrier before you put your final sheet on top. Sheet material, say plywood or whatever finishing materials you're going to have, and again that's just to try and avoid moisture getting through your insulation layers and getting to the cold surface of your vehicle to avoid problems in future. So the simple rule of thumb, very simple rule of thumb on insulation is put as much as you physically can. The thermal performance is a direct function of its thickness. So if I triple the thickness, I'll triple my thermal performance. It doesn't stop heat transferring, it just slows it down. So heat loss from 3 layers is 3 times lower than heat loss from 1 layer. So put as much as you physically can. Like I say, if you're going to insulate a home, you would put, believe it or not, 300 millimeters, a foot and a couple of inches of insulation in there of the Rockwool. Okay, you can reduce that down to 200 odd mil of 8 inches of Celotex, but that's really, really thick and really expensive. But if you're going to be in your RV particularly full time, or you're going to very hot or very cold climates, you'll be grateful for that. So put as much of that in as you can physically bear. And like I said, for me, and squishing it in is the wrong thing to do. You need to leave it in its natural state. So this stuff, don't put squish, because you're actually reducing its thermal performance. For the windows, they're 20 times more of a problem than your walls are. So what are we going to do about windows? Well, we can use the foils, the bubble wrap type foils, but really all they're going to do is reflect the heat back out. So the radiant heat that comes through the window, you can reflect straight back out. And there's lots of products out there that do a great job at that. But what you'll also find in hot climates is the inside surface of those feel quite warm. So what I'm going to do is I'm going to make up simple not boards, but patterns that fit my window. I'm going to put Velcro just on the surround, so I can just stick these in place. And I'm going to use a foil on the surface, and then behind that I'm going to put this type of material, a foam. Foam from bedding would be perfectly good. I'm going to put the foil on the surface of this, and on the back of this I'm going to put a nice fabric so it looks nice, and I can then just Velcro it onto my windows. And that gives me the best of both worlds. It gives me the reflective barrier, make sure it's not touching the glass, it's just a slight gap. It gives me a reflective barrier to reflect all that heat back out, and it also gives me insulation so I'm not conducting the heat into the vehicle as well. The other alternatives is that you can get, again, these foil materials that are plasticized, so they're flexible, and you can line the inside of curtains with them and make sure your curtains are felt or quite thick, so heat curtains, and that will keep heat out as well as keep cold in. But of course there's lots of gaps around that for ventilation stuff, so they're not perfect, but they're a much better solution. So windows you're going to have to manage with blinds or curtains or patterns like I'm talking about. There is another option that people have blinds that come down, and again they can have a thermal material on the back, so to a reflective material on the back, and they're just the heat blinds, and they just come down in a slot quite close to the window. That's another option, and they tend to have a thick material on the back that gives a little bit of conductive insulation, and they reflect the heat back out. So that's how you'd manage your windows. Of course, make your windows double glazed or triple glazed. That's good. You can get quite good performance on that, but that's pretty expensive. I'm fortunate when buying a coach, it will come with double glazing. I just need to make sure that if any of those units have lost their vacuum or have lost their argon, I take care of that, because I don't want to be running into 20 times more of a problem for my window space. The other option, of course, is you reduce the amount of windows that you've got. So in my bedroom areas, I'm going to be blocking up those windows with Celotex. I'm going to put foil on the outside because it's not going to be touching the glass to reflect the heat out straight away. That's radiant, and it's got a good thick piece of insulation on the inside. Just a note of where people wedge this stuff in. You can see that Celotex, the PIR type materials, is 1.5 times more performance than this. Use expanded foam, use a fire retardant expanded foam for all those nooks and crannies and cavities behind structural details and stuff. It gives you 50% more performance again, and it absolutely fills the cavities. So I'd rather do that than start wedging this stuff in. It's only a couple of quid for each can. It's money well spent. So that's the main insulation for heat. Repeat what I said. Expanded foam products like Celotex, PIR, half as much, again, better performance. You can get them thinner, or you can just get more in. Use as much insulation as you can bear. It will save you on your fuel bills, and it'll make your vehicle much more comfortable. The roof, of course, sun beating down, your roof will get hot. If you take care of anything, make sure you take care of your roof. You can always park your vehicle in shade to help, but really, if your roof isn't treated, you will feel the cold and you will feel the heat. And if you get any metallic details going from the front of your vehicle to the back, to the inside, understand they're over 1,000 times more conductive, and you need to put insulation around those to the same extent that you put insulation everywhere else. And if you don't, those are going to become your bridging points, they're called. They'll be cold, you'll get condensation and mould in those areas. I've seen people convert vans, and for the structural struts that stick out, they just put a bit of carpet on. Well, that carpet's going to feel cold, and it's going to get mouldy over time. If you don't use a vehicle very often, or you keep it well heated and well ventilated, it might not become a problem. If you're not using it in winter, it's not really a problem, but just understand that that area is sucking out the heat, because it's that much worse performing it from a thermal point of view than the rest of the vehicle. Quick touch on sound. Like I said, if you're trying to manage sound, use as much of this stuff as you can, the mineral fibre type products. Some call them acoustic, some call them not. They're all really good, so you're using any, you're going to get good results. If you're trying to, if you're building walls either side of a toilet, for example, then use this stuff. If you want more privacy in your toilet to sound deaden sound, use draft excluder around the door so it makes an airtight seal. Draft excluder at the bottom of the door. Put the light on in the bathroom. If you can see any light, seal it up, because if air's transferring through the room, then so is noise. Where your wooden stud meets the wall of your vehicle, make sure you seal all of that. You can use a special product called green glue. Actually, silicone sealant for those gaps will work perfect well for the bathroom. Just seal every single gap. Make sure there's no way that air can go into the vehicle from the bathroom. Helps with smell, but it certainly helps with noise. Don't use single skins. Use a stud wall and use this stuff inside it. If you want to get even more anal about that, when you put your stud wall in, put a rubber layer, get some thick rubber tape. Again, the green group people will provide you this, but a rubber tape or rubber medium between your stud and the wall or the floor. Put that rubber medium round and fasten through that, and that'll damp any vibration and noise that's trying to transmit through the wall. It'll help damp it, and make sure that the wall itself isn't quite touching the stud face, isn't quite touching the wall, and again seal with a bead of rubberized material. Silicone sealant does go hard over time, but it's still a rubberized material, and it'll reduce the transmission of vibration. So if I'm talking at the wall of my toilet, that my voice will make the wall vibrate slightly, and then it'll transmit through the stud timber to the other wall and transmit that noise outside. You can take it a bit further, and the face of your stud wall, again there's a little diagram to explain. Again, you can put an isolating medium, a thin layer of rubber, or if you put some silicone sealant on the face of your wall before you attach. Gluing on is better because the screws become a hard point between the face material and the stud. So if you can glue it on with a rubberized glue, again green glue is perfect for that, and then you minimise the places it's attached, then you can isolate the effect of that wall becoming a speaker. Okay. And like I said, make sure you seal your door. So that's how you get privacy in your RV. The other thing that I've seen people do is they've decorated the surface, the outside, using a fabric with foam behind and buttons. Looks like a surface of a sofa, I guess. Again, that provides a great noise deadening barrier, so you can maintain your modesty inside your room. So that's thermal insulation. If you want to insulate around your engine bay, or where your engine is, there's proprietary products called acoustic blankets, and what they tend to be is a layer of this kind of stuff, very, very thin, of foam, a layer of rubberized material, and then a layer of foam, and then they're both covered with a face sheet to keep it nice and together. Rubberized foam, exercise mats, yoga mats, this kind of stuff. That's what it is. It's very, very similar to this. So if you buy acoustic rubber, it can be quite expensive. This stuff, cheap as chips, and does a very, very similar job. And what it basically does, it adds mass into the damping system, and takes out those big vibrations. My mouse mat is also made out of the same stuff. So, and what they also do is they use a silver foil often as well, because they're trying to manage heat as well as sound. So you can use rubber mats like that. So when I'm doing my floor, what I'm going to be doing is I'm going to take the floor surface, I'm going to use some rubber mat like that first, just glue it down. Then I'm going to put Celotex on. Then I'm going to put a vapor barrier. Then I'm going to put Celotex on. And then I'm going to cut channels with my silver foil upwards. I'm going to cut channels and put underfloor heating, water heating in there. And then I'm going to put my a wooden chipboard surface to that, and then carpet or tiles on top. And that's going to give me acoustic insulation as well as thermal. And then, like I said, when I'm building my stud walls, I'm going to isolate the stud wall from the surrounding structure with that kind of rubber. Glue it on, minimise the connection points that I have. I'm going to drill the holes for the screw, then fill it with silicone sealant and screw in through that silicone sealant. So it's just the head will hopefully have a little bit of sealant underneath it. That kind of thing, just those little details to isolate the noise. The other use of insulation, which I mentioned earlier, is my hot water tank. I lose heat out of my hot water tank. Now, the people who make your hot water tanks put an amount of insulation on that makes them commercially viable. You double the insulation, you're going to double the heat that you can keep within the tank. So I'm going to make up some thermal blankets using this kind of stuff, and I'm going to pack my tanks as much as possible. We all know that you can get foam rings that clip onto your pipes. Well, that's a PIR equivalent type material. Get them as thick as you can and insulate everything as much as you can. So I'm going to do that. And also my fridge. The fridge is an interesting one because there's studies that people have shown that the heat, everybody knows that at the back of the fridge there's a compressor at the bottom in kind of a box, and it can buzz. That's where the noise comes from. But also that compressor unit gets quite hot, and immediately above it is the box for my fridge. Yes, there's some silver foils and there's insulation, but it's only about yay thick. Well, if it was yay thick, even less heat would be going into my fridge. So what I'm going to be doing there is I'm going to be using loft insulation because it's fire retardant. It copes with high temperatures. I'm going to be packing as much of that as I can above my compressor without covering up my compressor because it still needs to lose heat. I'm going to make sure that any heat that comes off my compressor is vented to the outside world, not transmitting upwards into my fridge. If there isn't a silver foil, I'm going to put a silver foil on there as well, and around the sides as well. So heat can only go out the back, and I'm going to make sure there's a little vent. Studies have shown that can improve the efficiency of a fridge by up to 10%, just doing that. And likewise, the radiator on the back of the fridge that conducts the heat out of the coolant material can also conduct heat into your fridge. So I'm going to put a layer of insulation, this stuff again, down the back of that to isolate that from my fridge. And also, if I have any space around the outside of my fridge at all, or the stud walls either side, I'm going to make sure those are as insulated as I can, so that the only part of my fridge that's not insulated is where my radiator and my pump vent to the outside world. Everything else is going to be insulated. And I've seen a guy do all of this anally, I have to say, but he did a great job, and he got to 25% reduction in the power demand out of his fridge. That's well worth having, because fridges are one of the beasts that suck up your electricity or gas. So insulate those hot items in your vehicle, and you will save energy. Heating water, cooling your fridge or freezer. Talking about heating and cooling, if you have an instant water heater, then okay, they're very efficient because they only heat what you need. But the pipe work between that heater and where you take it is going to take heat out of your water. So again, insulating all pipe runs. Never mind the fact it protects them, but that's still worth a little bit of effort. And that kind of pipe insulation is cheap as chips. So why wouldn't you? So I hope you found that useful. I hope I'll give you some pointers. As usual, if there's lots of comments, just send them in. And I look forward to talking to you next time.